the basis of this talk is going to be ANPR. I am not by any means an expert in image processing. I'm not an amateur. I'm really just a beginner. So please be kind. It is not done the correct way. A little bit of the background. I got involved with our neighbourhood watch. They had this thing about we're going to do cameras, and I qualified. I owned a computer, and I was under 70. So that got me right at the top. So we got a test camera, and it went from there. A quick intro to that is if you're doing it in your neighborhood, you're probably going to want to have the cameras not in front of your yard, but actually at important crossings, which means Wi-Fi becomes a very important thing, or fiber if you're really, really rich. So if you do get to that point, join a local WUG, do some online tutorials. MikroTik Ubiquity kits are like 600-700 Rand each. Buy some, play with it. Good luck. It's not the fun part of building a camera network. Okay, then in terms of cameras, there are many good options these days. Vivotech, Axis, just a whole list. Just be aware of the cheaper cameras. You get thermal drift, and then in the morning you've got a nice crisp image. In the late afternoon it's blurry, it's horrid. You get light sensitivity issues, the image sensors are rubbish, that kind of thing. Okay, then to get number plates at night, do take extra care to get something with a very good sensor, good optics, and a configurable shutter speed. Okay, so before we get to the algorithm part, getting good images is the very first thing. If you've got crappy images, you are never going to recognize it. That is clearly not recognizable, and that is what's the typical thing that happens when your shutter speed is not short enough, and you've got this back reflective number plate. So at that point, you need to take a couple of things into account: the car speed, the travel speed, the angle to the camera, which means the length of your shutter. Obviously, that time the car is going to travel, and if it travels, say, 10 centimeters, you're going to get a 10 centimeter smudged image, and that's obviously not going to work nicely because you're going to have a nice white picture. So the shutter speed and the light and the sensor quality plays a role there. After a lot of tweaking, this would be typically what our evening videos look like, early evening, and later in the evening it'll look like that. We've got heaps and heaps of IR that we put on it. I'm not certain whether it's legal, or it'll make people legally blind by looking into it, but you can't see it, so we've not had complaints as of yet. Okay. So getting to the actual NPR bit, I am not at all comfortable with programming computer vision. So if I did this wrong, please don't judge me. It'll be on GitHub. Fix it. So I used CDD, conference-driven development, for this. I've been putting this off for I think 4 years. I did a C++ Python hybrid app long time ago. I lost the C++ source. I had a bunch of magic in there that worked for some reason, and I couldn't replicate it, and I just kind of left it alone, and then someone said, let's redo this. And yeah, the conference forced me to do it. A bit different than test-driven development, but it goes. Okay, so the basics of NPR, you start by pre-processing and cleaning up the image, converting the color space, stuff like that. You localize where there are possible number plates. You take those out, you try and skew it so you get the thing more or less upright and in a straight line. You find the characters, you copy them out, you recognize them, and then maybe you do a bit of post-processing looking for a GP or an MP or CA or whatever. But that's in short, how you do number plate recognition. Okay, so at the preprocessor stage, you equalize. You might do a histogram equalization or a bit of normalization, maybe resizing. Really, it depends on your cameras. If you've got cameras that squish the images, you might want to normalize it so it goes in a similar fashion into the recognizer. Color space preparation. Typically, you're going to do black and white because at night you'll only have black and white, so there's no benefit to color. So you'll drop that. Then the number plate localization. Couple of techniques. Do edge detection. Basically, do an edge detect. I'll show an image in a second. You count the amount of edges and you look for places where there's a lot of edges, and yeah, that must be a number plate, or the number of the plumber on the back of the bakkie or whatever. Then you get what is called a top hat morphological operation, which is very similar, except that it looks only in I think a 3x3 area for a specific. Well, actually, you can define the size, 25x3 or whatever, and it looks for certain things in that area. Then you get HAR classifiers. I don't know if you guys have ever seen a little camera. The draws a nice little box around it. That's done with HAR classifiers or with the integer equivalent, which I can't remember the name of now. And then character detection is the other one, which is more of a blob technique where you try and find characters, and that's what I used. Okay, so this is the edge detection, and then you'll see clearly where there's a lot of edges, you get these kind of peaks, and you then copy that line out and redo this for the vertical, well, first vertical, then horizontal, or well, first horizontal, then vertical, and then you more or less get a number plate. That works really nice when you have got a constrained size. You only have the car, you don't have the nice growth next to the road or the railing of the highway that's got a million bars on it. So it depends on what you're doing, but this is not a particularly good technique. This is the top hat morphology. You can see all the edges are pretty clear, but are highlighted. The rest of the image are basically filtered away. And nicely, the number plate is relatively highlighted. After that, you do a bit of blob. You do, what are the, can't remember the name now, erosion and dilution, or erosion and, in any case, you basically throw away all the thin bits, and the thicker bits you convert into blobs, and then you recognize the blob, and then you have the area. Okay, then character detection, which I did for the localization. The reason we do this is you've got high contrasts in plates. It's white on black, black on white. It's similarly sized. All the characters are of a similar size, similar width, height. They are closely positioned together. They are always more or less horizontally, unless you installed your camera horizontally, which would be stupid. So basically, you start with an adaptive threshold. Nice little line of code there. Single line in openCV. Go do thresholding. Boom. Spits out a beautiful thresholded, adaptive thresholded picture. It actually uses a kernel and slides over the size. Actually, I've got that defined as a window size, but you can define a 25 by 25 pixel area, and it does an adaptive threshold in that. So it gets the average and then does the thresholding based on the local average. This helps a lot for headlights and the sun reflecting off of stuff and partially shaded number plates and stuff like that. Then you detect all the blobs. You use a standard CCA technique or contouring. I was lazy, so I used the built-in openCV contours. Single command, give me contours. It spits out a list of contours. Really stupidly easy. Then you take each of those contours and you check whether they comply to the size. So beforehand, you've got a little bit of config for your camera. You say a character will never be bigger than 80 pixels or 20 pixels or 30 pixels, and never be smaller than, and that's more or less what you do to tweak it. And quickly to show you what you get from that, this would be the adaptive threshold. You can see the characters are nice and visible. Unfortunately, there are quite a few regions of interest. So once you've done the size and an aspect ratio filter, there is still a bit left, but a lot less. And then you nice line, all of them close by and next to each other, and boom, there you have nearly all the characters, not all of them. After you've done that, you take the area, you feed it back in, you skew correct. There are two. You can deskew or rotate. The deskew, I think, is actually a perspective transform. So you find the edges of the number plate, and if the plate is at an angle and the back is thinner or that kind of thing, it'll correct for. Because we are typically 50 meters away from a camera, from the number plate, the camera is going to be next to the road. You don't get a lot of image skew in that direction. The size will be more or less homogeneous, so you don't really need that. The reason we don't do that is because a lot of number plates on white cars, you might not actually see the edge of it. There might not even be an edge. It might actually just be cable ties holding it on, I don't know what, maybe super glue. It's really, when you go to Europe, these techniques work very well. When you're in South Africa, you need to be a little bit more adaptive. So what we do is the rotate, and it's very easy. We've got all the blobs. We check the top edge of we draw a line, an average line through the top edges and through the bottom edges, and we rotate, and we get this, just to give you an idea from the previous image, which is not terribly skew, but skewish. We get to this, we do a black and white, again, adaptive threshold, and we get the blobs, and we redo the little bit where we find the blob sizes, and then we copy them out, and it's really that easy. So I had to say at the beginning of this talk, this is going to be a really quick talk, and hopefully with a couple of questions, which I will probably not be able to answer. Okay, So the character segmentation bit, that is where we actually pull them out. We do adaptive threshold again. We again do the connected component analysis or the contour. We find the blobs, we filter it. The only difference this time is we are a little bit more strict on the size. Because we've already rotated the images to be in a upright plane, we expect them to be nigh on the same height. So we typically have about a 1 pixel variance at this point, and that gives a little bit more accuracy. We copy them out, and we feed them into the character recognition bit. Unfortunately, that's the bit that really trips me up. We have an average set of characters which we painstakingly built by hand by cutting them out and copying all the A's into a folder. How many A's do you find in GP number plates? You have to wait for the guy with the Karina number plate coming by, and then you get 2. Luckily, I have a science GP and a Karina GP in my neighborhood, and that helps a lot. And then, we physically just for getting the training data for the ANN, copied it into different folders. We built averages to check whether that works. It sometimes does when the sun is right and it's before 2 p.m. Training an ANN worked better. We use a 30 by 30 image. We have 900 inputs, 36 outputs, between 200 and 250 the middle layer worked out most efficient. I assume it actually just memorized it and didn't really properly generalize. So what we saw is the ANN that we built with the C++ code works great on the 2 cameras we trained it on. It really has about 99% accuracy. It's wonderful. And just by changing from a little bit of code onto the Python, we are seeing more like a 90% to 95% accuracy on the characters, and even lower for some of the other images. So I have to retrain it, and that is fun. So I'm actually now looking at deep belief networks, which is a kind of neural net that I am hoping will just do magic, import, no learn, train, done, but we'll see. And then there's other tools we've tried using Tesseract. That doesn't work at all. It doesn't like single characters. It's just doesn't do it. And then any suggestions? Yeah, please. That's going to be, I'm hoping someone will give me a suggestion there. And then, by image search, very good website. If you ever want to do a little bit of image processing, please visit them. The guy he had a Kickstarter now. He's building a nice big course on it. But he's got all kinds of cool stuff, finding faces, patterns, classifying flowers, all kind of just weird stuff. Adrian, can't remember his surname. So I got a couple of samples from his site, and some of it off of, I'm pretty sure, Stack Overflow. But I've refactored it so no one will know it's not mine. And questions? Oh, no. One last thing. We are actually in the process of working with a guy in Joburg that has access into the Unicode database, which is the police's lost or stolen or at least reported crime number plate database. And that is actually one of the things that will probably make a big difference in this project. Up until now, the biggest use for our system has been we catch a guy, he looks suspicious, he says, no, he lives in the neighborhood. And then you check on the number plate, and he's been like there 800 times or 1,000 times. And, he's either the stupidest, uselessest thief ever, being in the neighborhood every day for the last year and not stealing, or he's telling the truth. So in either case, you can let him go. And we actually had one arrest where we incidentally, me and a friend was discussing the number plate recognition system for their neighborhood, and we had a sample of a guy we suspected to be a criminal. He disappeared between 2 cameras, and there was a break-in. And when this guy drove out, he actually saw the number plate. So the NPR system was down, but because of that, we could actually identify the guy. And then when we caught him, he said he's driving erratically because it's his first time in the neighborhood, that kind of story. And we got the system up, and we did a quick check, and he had been in the neighborhood about 15, 20 times. And we could actually we could show that he was a liar, get the police out, and they found a bunch of drugs on him, and poor drug dealer got arrested. So yeah, not the criminal type we really want to catch, because clearly someone in the neighborhood's buying the stuff. So, but in any case. Yeah. So, yeah. Any questions?
Thanks, Dewald. So you talked about cameras. As someone that actually wants to get into the whole, I want to get a bunch of cameras that can do night vision and look out, that kind of thing. Advice?
Do a lot of research. The cheap Chinese stuff doesn't work. Stay away from that. But if you go for any of the bigger known brands, Vivutech, Mobotics, Axis, there's a bunch. The best thing is to try and find someone who already has one. That'll help a lot. So you can actually go check go into the setup, see if you can limit the shutter speed. You can typically set it to 1,000th of a second or 100,000th of a second. If you can't go below 100th of a second, you're wasting your time. Second, anything that can screw a different kind of lens on it. So you can buy a long, massive 50mm lens and you can punch in to have that one street lane appear as a 2-megapixel camera from 50 meters. That helps a lot. Okay. And they cost a bit. You know, you're going to probably spend 1,500 on the lens and 5,000, 6,000 or 10,000 on the camera box. But at that point, you'll have a good camera, and you'll probably buy decent enclosure with a little bit of IR in it, or buy nice big IR LED lights and mount that, and hopefully not blind people.
Okay, so all right.
Yeah. Or find me afterwards, and I can show you what I did in my neighborhood. It's not difficult. Find me afterwards, and I can just, yeah.
So you keep like referring to infrared, okay, and then running away again. So do you need to change the cameras for infrared? It's just heat, right?
Yeah, well, it's near infrared, not far infrared, so it's not thermal. It is the infrared that kind of glows reddish. If you take a cell phone camera and you point it at it, the little infrared filter on the little piece of lens there, they put an infrared filter coating on it. If you point one of those, or especially a cheap cell phone, so if you've got a Samsung or iPhone, it's not going to work, but cheap Chinese junk like mine, you point it at it and it looks like a spotlight. But your eye recognizes it as maybe a slight red color to it. It's standard infrared LEDs you can buy. You can also buy halogen lights and put a nice piece of black perspex in front of it. That'll let the black perspex actually lets infrared through. Although you'll spend quite a bit on electricity, so I would not advise that, and you'll probably have a melting effect after a while, because we did that and we melted the system and blew someone's power. But that's one of those you learn with time. We couldn't really buy in South Africa, so we imported these massive, it's LEDs like that, and it's in an array of 50 or 30 of them or whatever. It's 50 watts worth of LED light, and it's on a 15-degree angle, so it really just, it's like a spotlight. It's not quite a laser, but it's getting there. We do projects with the guys at the NLC, the laser center at CSIR. We're just below the CSIR. And one of them asked about it, and he was like, you should be wearing goggles for this. So that's why I mentioned we might be blinding people. But yeah.
You mentioned that you're taking photos of things.
Yeah.
Have you tried like getting, these NVR type recorders that can maybe freeze frame from a video feed? Have you played with that? Does it have more blur to the image?
What those guys do is they just record a lot of images. So they are recording H.264 or MPEG-4 or whatever.
Yeah, but I mean, you've got the image differential between frames and stuff. That will give you a very blurry result by itself.
Well, it depends on how you set it up. If you set up the MPEG-4 or H.264 with a high enough bandwidth, it'll actually be crisp every time. The bigger annoyance is actually getting an API to get into their system, because they have proprietary formats and they split it up into 1,000 little bits, and to manage the files, obviously, but it's a hassle to find what to process. So what we actually end up doing is we've got a recorder sitting on one side. I've tried many times to get video from it. I've given up, and now I suck on the JPEG stream directly, and I'm moving MJPEG over my
Okay, so
Wi-Fi.
you're basically pulling the MJPEG at
Directly.
frame intervals, or?
At the specific cameras I use, Vivutech, you can set up how many frames per second, and to not kill my network, I put that to 2 or 3, and if a car comes by that 400 meters, or let's call it 100 meters stretch in a third of a second, we're not going to get that number plate, and we're not going to catch them.
And you're doing motion-activated transmission?
Well, actually, we're doing, on the Python side, ironically, we've got a little bit of Python just sucking the MJPEG in, doing a diff, just chops, and then a histogram, and counting everything that changed, I think, more than 15.
So you're excluding shadows and...
Yeah, mostly. Sometimes we get them. But the top hat thing I just showed, the one where you've got a kernel morphological top hat that gives you an idea of whether there's a number plate, will probably be the new technique we're going to use going forward. But for now, that's the stuff running on the server, sitting at home.
Then just one last question. Architecturally speaking, how big can you actually scale your network distribution-wise? Or aggregation-wise, rather?
One of the reasons we are redoing this in Python is to put this on a Raspberry Pi 2, to have that at the local camera, and to just push what we are doing as much as we can there, and just pushing the images. So then we can use 3G, so we can scale wider geography. In geography, we can drop something next to a big road, and as long as we've got 3G and maybe a gigadata a month, we should be fine. You can't push 3 frames a second all day. That's that's not going to be a nice bill to pay. So that's the one reason. We've got a Postgres server with a little bit of HTML and a Cherry Pie sitting on top of it, so you can search by date and a couple of things I can't even remember. Check the newest couple, and there's a SMS alert, and we had a SMS account, and I set my own number plate on it, and then cleaned out the account, and then decided to switch that off. And we've got an email which I think is not properly configured. So it's a little bit, yeah, we need to do a little bit of work. But if you look in terms of a neighborhood, it's going to be geographically constrained. You're probably never going to go above 30, 40 cameras. You typically are going to cover the main roads and not the small roads. So it should scale quite far. And the second you only push the images, you can really go the distance. I mean, Postgres will scale to millions and millions and millions of lines, and it'll do it quickly. And yeah, so I'm guessing you can scale it quite far as long as you've got the distributed bit. If you've got one big server, at this point, we've got an i5 that sits there and tries to process the images, and it has a nice memory queue that just grows over the rush hour, and it's half an hour behind, and then it catches up, and then it goes behind, and it catches up, and it's on 4 cameras. The second you go down to 1, it keeps up, but if you go up to 4, we've got the CSIR traffic going through, so that's quite a bit.
So you're asking for suggestions. I'm not an image processing person at all myself, but one of the things I've been hearing about is convolutional neural networks. I don't know if you've looked at that at all.
I just glanced past it, and the deep learning ones is the first I'm going to start with, purely because I've got some sample code that'll get it up and running. But yes, I'll probably go through all the different sets of neural networks, and the convolutional ones will be on the list at some point, definitely.
Thanks.
Unless someone else comes up with a magic bullet and says, put it in there and it'll give the character 100%, and well, just use that.
Cool. Here. There's someone here. Oh, right in front. Thank you. I'm blind.
Hello. I was wondering, have you tried something like openALPR?
Yes, I actually, I tried. I didn't find enough documentation on how to configure it. I still owe someone in Joburg a bunch of images because he's going to play with it. We got on I think on one of the forums, we were trying to get the stuff to work for South Africa, but that would have been a much easier program. Import OpenLPR.
Because I played with it a couple of months ago. I actually gave a talk on, I mean, I basically played around with the same stuff.
Yeah.
I just used OpenAPL. I got it configured on a Raspberry Pi 2 and got it working, at least in the tests.
Yes, however, it's actually quite slow. OpenLPR is very, very thorough. It actually goes through where once it gets the region, it actually processes that a couple of times with different settings. It's better, but it's I think 15 seconds per frame on a.
For my use, what I'm using it is not for an entire neighborhood, just for one complex going through the 2 gates only. So for my implication, one Raspberry Pi 2 with 2 cameras, whatever.
Yeah, that'll actually work quite nicely.
Yeah.
I did think about going that route.
I mean, if you want, I actually have the tutorial I put up on GitHub, so I can share it with you as well.
Yeah, please do.
Okay.
I'd like to see that. Yeah, cool, thanks.
Steal each other's code. Some people back there. I'm going to go back there. Because I went all the way back here and then I ran away. Lots of questions back here. If I can. Yeah. I'll start
So not a technical question, but how do you deal with the privacy aspects of what you're doing?
Yes. we when sharing any data, I put it through an anonymizer. If I do share I've shared with Tikkies for the research purposes. We do a hard classify for faces and blur it before we send it out. And then if someone comes and wants to have any access into the system, we require them to first open a police case and bring the CAS number, and we check that. We are lucky in that we have almost no crime in my area. We've gone down to the position where I think we've got about maybe one house robbery a year, or not robbery, break-in a year. We have no armed robberies, nothing like that anymore. Much of it was things like the neighbourhood watch and 50, 60 people riding around with buckies and catching people, and I think the criminals just figure out this is not a nice place to steal. So from a philosophical point of view, I'd rather have it in the hands of a elected local community, elected representative of a local community. So we actually have a democratic system where we elect people into the local neighborhood watch. It's a non-profit organization that manages their local community. Then in local government's hands, because they are A, stupid, B, incompetent, and C, probably evil. I don't know. It's probably all of them. So you don't want them. I'd rather have them access number plates through a local community, because the local community can always cut that off and kill it. And they'll probably, once there's something built, they won't try to rebuild it because they're just lazy and stupid. Sorry, I hate my city government because they've caused us hundreds of thousands of rands of damage because of laziness and stupidity. So, a bit outspoken, but that's just unfortunately what it is.
Is there some guidelines or documentation or something for how you've set up your neighborhood watch? Like
the neighborhood watch or the camera bit?
Well, everything that's part of it. Like if you want to get your neighborhood watch to sort of run itself more efficiently and do all of these things.
There's a couple of groups that do this as a business. I don't know how good they are. A specific guy named Jan Malan does this. He helps areas close down, close their borders, and set up a process. But quite frankly, I would say Google and go talk to a couple of them. There's a couple of guidelines, there's a couple of things. You need to have some tactical training for the actual tactical people going out. You need to have plans on how you're going to deal with different things, medical emergencies, crime emergencies. You know, are people going to run around with guns and shoot people? That's not a fun thing to do. Or it might be. I mean, if people play Quake. So really, it depends a lot on your neighborhood. It depends on your crime. It depends on what the whole thing looks like, the participation. There are hundreds of models. You can go talk to ADT and they'll do it for you, and they'll keep robbing you because they're probably the criminals themselves. I don't like security companies. They tend to be horrid. But at the same time, you need them. So it's really, go find me afterwards and I'll give you a couple of numbers of people to talk to, and they'll be able to tell you what they did and how they did it.
Cool, thanks.
Okay.
There was someone over that side, yeah.
Why don't you make your number plate images it doesn't even have to be the whole number plate, it could be the cut up individual characters. Why don't you make that data publicly accessible somewhere and ask if somebody's keen on trying to solve the classification problem?
I would consider that, yes, purely because, that's a good idea. There's a bit on the heavy side on data. It's about a terabyte worth of images I've got, so I'll probably share a subset, but
sure.
That's actually a good idea. I'm going to put the code on GitHub at some point for tomorrow's tutorial, so we'll fix it and then put it on GitHub, clean it up a bit. And then I'll put some images in there, just maybe a 10 meg or 20 meg worth of images.
It's a fun, it's not just a useful project, it's a fun one as well. I imagine you'll actually get quite a few people.
Yeah, cool, thanks.
Any other questions?
Okay, thanks guys.
Cool.